board. Let's click on Online Modeling Lab 4. And let me click reset and start. And today we're going to look at externalities. Does anybody know what an externality is or got an example of an externality? Positive or negative?
Can you repeat that question?
Yeah. Can you hear me?
Yes, I can. I just didn't hear
Okay.
the question.
Yeah. So we're going to talk about externalities today. Maybe I need to blow this up just a little bit more. There we go. So today we're going to talk about externalities. If you're talking about a negative externality, you can think of pollution. Pollution would be a negative externality. And to some, one's negative externality would be another's positive externality. Like, for example, if Metallica, my favorite band, if Metallica, you might have heard of Metallica maybe at a basketball game or football game when they play Enter Sandman. That's Metallica. And it's played a lot at sporting events. But if Metallica were to give a free concert on Argyle Road in Brooklyn, and it was free, I would consider that a positive externality. I suspect all of our neighbors would consider it a negative externality. Another example of an externality is this morning when I was walking my son to one of the triplets to school, at 7 o'clock in the morning, a car drives down the road, the windows are rolled down, and the speakers are just blaring the song that the driver obviously loves. It's 7 o'clock in the morning. Now, 4 o'clock in the afternoon, I might consider that positive externality, but at 7 o'clock in the morning, I would consider it a negative externality, right? And then pollution. Some people consider CO2, carbon emissions, as a negative externality. Personally, I don't think of CO2 as pollution. CO2 is plant food. Plants absorb it and the sun, and they turn the minerals in the water and whatnot. There's a chemical reaction in the leaf that takes the CO2, combines with sunlight, nutrients, and water, and uses it in photosynthesis. So that's how plants grow. And in that process, they give up oxygen. So I personally wouldn't consider CO2 a pollutant. But a lot of people do. Politicians do. Young people might consider it a pollutant. But I personally don't. A pollutant is like, to me, a pollution is like carbon monoxide. In the movie Taken, in the movie Equalizer, Denzel Washington's character has that corrupt Boston cop in his garage, and he's got a hose going from the tailpipe into the car. And if the guy doesn't give him what he wants, if the cop doesn't give him what Denzel's character wants, then Denzel's going to leave him in the car with the tailpipe. Well, that tailpipe is spitting out carbon monoxide, and carbon monoxide will kill you, right? Now, CO2 can kill you too. If you breathe too much of it, you can die because you're not getting enough oxygen. But carbon monoxide is more poisonous. So I would consider carbon monoxide a poison. I don't understand why CO2 is considered a poison. I just don't understand that. Water vapor, too much water vapor in the air creates greenhouse effects. Methane creates greenhouse effect. I would consider methane a pollutant. So to some, a negative externality is a positive externality and vice versa, right? So I guess society has to decide what are the negative externalities and what are the positive externalities, and then decide what they want to do with it. One way you can take advantage or take care of an externality is you can tax it. When you tax something, what do you get? Do you get more of a good or you get less of a good? When you tax something, do you get more of it or do you get less of it?
Isn't it less?
You get less of it, right? So if cigarettes are considered bads, not goods, but bads, bad products, bads, not goods. Goods are products that do good, generally speaking, right? So maybe politicians want to consider cigarette smoking and secondhand smoke. They all consider that a bad, right? So one way to reduce its consumption is to tax it, right? And you get less of it. So we're going to do a taxing example. So this particular example overlaps a couple chapters. It overlaps to chapter 3. It overlaps externalities. It overlaps tax incidents. So it overlaps quite a few chapters of our textbook. And I personally like it because of the story I'm going to bring up while we're going through it. I'm not sure, have you guys ever heard of Eric Garner? Anybody heard of Eric Garner?
I think so.
He was a black man who was selling loose cigarettes. They call them Lucy's in New York. He was selling Lucy's in New York City on the street corner, or accused of it, right? And the bodega owners, you have to wait until 5. Okay. I'm on a Zoom call. No, because it's my hiding spot. At 5 o'clock, you can have it. All right. Sorry. Yeah, Eric Garner was selling Lucy's outside of, accused of selling Lucy's outside of grocery stores. And this is pretty common in New York City. People are selling them left and right. And in fact, if you watch this video, you'll see that most cigarettes sold in New York City are sold illegally. And when I brought this up, when I first brought this up in a class that I taught at A&T years ago, more than 10 years ago, yeah, more than 12 years ago, maybe 13 years ago, when I brought it up, one of the students in the class, it was a white student. She was a white student, and she was getting her teacher ed degree, and she was taking my micro class. And she said she goes to the Indian reservation in Pembroke, I think, North Carolina, and she would buy boxes of cigarettes duty free, and then ship them to her uncle in Long Island, who would then sell them to probably people like Eric Garner, who would in turn then sell them as Lucy's on the street. So I thought that was pretty interesting. And anybody understand why? Anybody know why more cigarettes are sold illegally than legally in New York City? And we want to fathom why that is?
People underage.
Well, yeah, underage people are going to buy cigarettes that are addicted to them, right, or want to look cool, or peer pressure reasons. What they want to buy them, right? Because they can't go into a store and purchase them because they get ID'd, right? You got to be 18 or older to buy cigarettes. That might be one reason, right? What might be another reason? It's related to the same reason why more pot is sold in New York City illegally than legally. And the same is true in California. In California and New York City, you can walk around New York City or a street in California and smoke pot without getting busted by the police. In fact, it seems like everywhere I walk in New York City, especially Manhattan, I'm walking into somebody's plume of marijuana smoke. So it's really common here, right? But it's for the same reason that illegal pot, more people smoke illegal pot than they do legal pot. It has to do with taxes. The taxes are really high in New York City. The regulations are really steep, really onerous. And the licensing is very rigorous. The same is true in LA. So you have the highest cigarette tax in the country in New York City. The highest. I mean, a pack of cigarettes might cost you $3 or $4 in North Carolina, but it's going to cost you like $15 to $20 in New York City. I don't know what the current prices are because I don't smoke, but they're really, really high. And so when a tax gets that high, it drives a lot of commerce under the table into what is called a black market. It's called a black market because it's done in the dark of night in the alley of a city. There's an episode of Seinfeld where Kramer and Seinfeld, Jerry, buy a shower head in the alley in the dark of night. They're buying black market shower heads because the super put in low flow shower heads. So that's why it's called black market. It's in the dark of night in the alley, right? With no lights, right? So these things form, right? And that's why we have a drug war. Drugs are illegal, but yet people choose to consume heroin, crack, and methamphetamine, right? They choose to do it. They've made it illegal. Making it illegal does not stop the demand for those goods, right? People still want to consume it. So that demand has to be satisfied by somebody, and it's usually satisfied for people who don't care about the law, and the cartels run drugs into the United States across the Mexican border, and even though it's illegal and they're not allowed to do it. They do a lot of illegal things like smuggling humans and kidnapping women and probably selling them into sex slavery brothels, right? So all this stuff is illegal, but yet it doesn't stop it, right? And so we have this drug war that I think is ridiculous, and I think it should be ended immediately. We shouldn't be putting people in jail for their desire to drink certain beverages or consume certain substances. To me, it's their body, their choice. If they want to ruin the life, I guess that's their choice, right? It doesn't stop it. That's my point, right? And so these criminal gangs, groups called cartels, are probably selling a lot of the illegal pot in California. I suspect they're probably selling a lot of the illegal pot in New York City, and they're selling the crack, the methamphetamine, and heroin to the dealers on the street. So that's what you get. You get these illegal markets, right? You get these illegal markets when you tax it too heavily, or you out and out ban it, make it illegal, right? Now you got Republican politicians wanting the next Republican president, calling for them to go to war with the cartels. Well, what is that going to do? You might be successful in that war and kill off some mild-mannered cartelists, but who's going to replace them? Even more hardened individuals who are more murderous, right? Why? Because there's a market for these drugs, for these products, and people want to purchase them for whatever reason, right? So one way to, if you consider cigarette smoking an externality, you can tax it. So let's look at what happens when we tax it, right? We're going to look at a model here, right? If you read this article here, New York City has the highest cigarette tax in the country, and then 714,000 New Yorker city residents smoke. That was in 2021. The average smoker in New York State smokes about 17.9 cigarettes per day. So in the United States Navy, we did this in nuclear physics. We put things in a table like this, and the things on the top are being multiplied by each other. The things in the bottom are being divided into them, right? So we have 714,000 New York City smokers. They're smoking 17.9 cigs per day. Each New York smoker is doing 17.9 cigs a day. And then we have 365.25 days per year, right? Because we have, the leap year every 4 years, right? Where February has 29 days, right? So when I multiply 714 times 17.9 times 365.25, what do I get? 114,000 times 17.9 cigs per New Yorker. Notice that New York City smokers cancels, right? And I'm going to multiply that by 365.25 days per year. So day cancels. We get, I think that's 4.667 billion cigs. So let me copy this. So 10 to the 9th, right? What is 10 to the 9th? Well, we got to move the decimal place 10 places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here we go. So that's, again, that's in billions, right? It's in billions. That's a lot of cigarettes, right? A lot of cigarettes smoked yearly. 4.7 billion cigs a year. That's a lot. See, this market is huge, right? This market is huge. Okay, so down here, we made an assumption. Your demand and supply curve will be different than mine. My demand curve is this equation because the slope is negative. And what that means is as the price goes up, people will tend to buy less cigarettes. They'll demand fewer and fewer cigarettes. The supply curve, this is the supply curve because the slope is positive, right? What this says, as the price goes up, holding everything else constant, if you hold your costs constant, as the price goes up, margins, profit margins go up. And for higher cost producers who may not normally supply cigarettes, if the price gets high enough, because they have these high costs, the price has to get high enough for them to jump back in the market and sell cigarettes. So as the price goes up, generally speaking, more and more firms will start selling cigarettes. The existing firms will probably want to increase the number of cigarettes they sell too, right? Because the price is going up, right? So that's the supply curve. And the supply curve is more elastic than the demand curve. The demand curve is more inelastic, right? The way I remember elastic and inelastic, that doesn't work. I bring open up Notepad. This is how you remember elastic and inelastic. Whoop, my Notepad won't move. There it goes. Control plus. Elastic, notice the flat line right there. See the flat line right here on the E? Flat line. Everything else is curved. You have that flat line. You can think of that as a perfectly elastic demand curve, right? And then the I. The I is a vertical line, right? So perfectly inelastic line is straight up and down. Perfectly inelastic supply or demand is perfectly, it's a vertical line, straight line, up and down with no slope, right? Elastic is a flat line, right? So that's why we say demand is more elastic than demand. And why is demand inelastic here? Demand's inelastic because people are addicted to cigarette smoking, right? They're very insensitive to a price change. If the price goes up, they still need to smoke their 17.9 cigarettes per day, right? Because you're addicted to it. So what ends up happening is if the price goes up and they're heavily addicted, they still got to smoke their 17.9 cigarettes per day. But as the price goes up, what do? Maybe they switch from fresh vegetables to canned vegetables, or they switch from Chipotle burritos to Taco Bell burritos, right? Or maybe they switch from Five Guys cheeseburgers or Five Guys burgers with lettuce, tomato, pickle, onion, no cheese, no mayonnaise, no ketchup, and they switch to a quarter pounder, right? So they may make those substitutions. They still have to have their cigarettes per day, right? Because they're addicted. And that's why the demand curve is more inelastic than the supply in this model. Okay, so what we're going to do is I'm going to copy the demand as well. We could just click on this right here, right? I'm going to click on the Desmos model and I'll move it over here on the side, right? Move it over here. And notice I already have a model in here, right? I already have a model in here. So what I'm going to do is I'm going to copy the 3.955.9. I'm going to copy that. I'm just going to copy the difference in the numbers, right? I'm going to paste that over the 4.05 minus 0.45. Yep. See what I did there? I'm going to do the same thing for the supply curve. Do the same thing for the supply curve. Okay. Now down here, what I want to do is I want to have a plus T down here. So what I'm going to do down here is I'm going to put a 405 here. This number here is that number there. That's the intercept, right? I'm going to set T equal to 0. Set T equal to 0, right? So this right here is the intercept. And this is the intercept. This is the tax rate, which we have currently set at 0, right? We have it currently set at 0. I'm going to change this to 0.1. So this right here is supply curve, right? It's a supply curve. But I'm going to include a tax, right? Now, to get rid of the supply curve, to make it disappear, I'm just going to click this right here. Well, actually, what I'm going to do is I'm going to make this tax negative 1,000. Then it's disappeared, right? Yeah. I'm disappearing it. I'm going to make the tax minus 1,000. So this is basically turned off, right? That's basically turned off. Okay. So does everybody have their numbers matching the problem that they have? Right. My numbers in my model match my numbers here, right?
For the last one, the supply curve, where'd you get that?
This one, oh, this is going to be the tax. We're going to impose a tax on it, right?
So you just left it how it was?
Well, no, I made, okay, let's just do this. Copy whatever is there and put it here.
Okay, for both.
Okay, so just this and this will be the same thing, right? You see that they're the same thing?
Yeah, I see.
Okay, then just throw in a plus T. Yep. Throw in a plus T. You put the plus T in the front if you want. Just do a T plus, right? So this part is identical to that part, right? Now, if T is 0, the red and black curve are the same thing, right? So if I click on that, I get a red curve. If I click on that, I get the black curve, right? You see that? They're the same thing over here, right? I clicked on the black equation, I get the black line. I click on the red equation, I get the red line. See it? The red and the black.
Yeah.
But I'm going to go ahead and make well, I can just leave it like that. I can just leave it like that. All right. So everybody has it set up like this, with number 3 being T equals 0 and number 4 being a copy of 2, but with this innovation. We're just adding T to the right side of the old supply curve. Okay. And you're going to see why we need that in the future, right? You can also turn it off too, right? You can also just turn it off. Okay, in the absence of the tax, the equilibrium quantity of cigarettes consumed annually in New York City can be found using Desmos.com, modifying the Desmos.com model. It shows the equilibrium quantity is 3.55 billion. So I go over here, and guess what what happens when I click on this point of intersection, right? This is the number of cigarettes in billions that are sold each year, right? This is in billions, so 3.55 billion. And this is the price per cig, right? Because how many cigs in a pack? I don't know, 20? I don't know what it is. 20? 12? I have no idea. I've never smoked a pack of cigarettes sober. I did it twice in my life. What? You can take it. What? Can you wait till 5 o'clock? I'm in a Zoom session. Joe. I'm with my students. Okay. Oh, you need this? So I don't remember how many cigarettes in a pack, but if you buy a pack for, I don't know, $20 in New York City, and there's 20 cigs in a pack, then each cig is $1, right? So you can put it on a per cig basis. So this is on a per cig basis, right? So the price, my price over here is 0.76. Right? You get that? That's my price right there. The second number is the price, right? The second number is the height above the x-axis. In this case, it's the quantity of cigarettes consumed. The quantity is 3.55 billion. The price per cig is $0.76 or 76 cents, right? Any questions on that? That's if you plug in the demand curve. Yeah. Whoop.
I said no questions. I'm sorry.
Okay, cool. Yeah. All right. Just making sure. Cool. All right. Now that's if we plug in the demand curve, right? So we plug in the demand curve. If we multiply, if we replace Q with 3.55, 3.55 times 0.9 subtracted from 3.955, in my case, would be 0.76, right? And I can show you that right here. Times 3.55. See that? I take the quantity, 3.55, I replace the quantity with 3.5, I replace Q with 3.55, and I get 0.76, right? I can do that down here too. I can put in, again, 3.55 in the supply curve, I get 0.76, right? Get 0.76. So what that tells me is the market price is $0.76 per cigarette, in my model. Roughly three-quarters of a dollar, right? I'll go back here and I'll replace this with Q, capital Q. So at this market equilibrium, the price on the demand curve, which is the maximum price consumers are willing to pay at that quantity, is 76 cents. If we substitute that in the supply curve, we get the lowest price firms are willing to accept to supply 3.55 billion cigarettes, right? Okay, now the governor or the mayor of New York City comes to you, the young economist, and says, all right, you've estimated the demand curve, you estimated the supply curve. We want to impose we want to reduce consumption by 20%, right? We want to reduce this by 20%, right? We want to reduce smoking by 20%. What is 20% of 3.55 billion, right? So the amount that we want to reduce consumption by, in my case, 3.55 is how much they're currently consuming, right? It's how much they're currently consuming in cigarettes, right? In my model, yours can be different. I multiply that by 0.20. What the governor or the mayor wants to do is reduce consumption by 0.71, right? The governor wants to reduce consumption by 0.71 billion. So by 710 million, right? So you could do this. You could take 3.55 and subtract off the 0.71. Right? You can calculate the reduction that is desired by government, the 0.71 billion, right? And you can subtract that from the current quantity of cigarettes consumed by New Yorkers, right? And you get 2.8. In my case, you get 2.84. You can also do it in one step. I could just multiply by 0.80, right? You just multiply by 0.80. Or, maybe better yet, I can multiply by 1 minus 0.20, right? I can do it in one step. Any questions on that? And so this over here, this is the goal the mayor wants, right? It wants consumption down to 3.8 or 2.84 in my model. Everybody's got green check marks? So the goal of this policy is to what? Is to reduce smoking, because smoking is a negative externality, right? Smoking is a negative externality. You want to reduce it, right?
For some reason, mine is coming up with 3 decimals. Or
I think you can put in 3 values. I have it set up so you can put in 3 decimal values. Oh, round dollars to 2 decimal places, percentages to 1 decimal place, and all other values to 3. So in this regard, you put in 3, but mine would, if I plugged in 3, I'd have to use 0, right? Yeah. So for these, you need 2 decimal places. For dollars, you need 2 decimal places. But for billions of cigarettes, you do 3 decimal places.
oh, I see it.
Yeah, it's fine. Okay. All right. Now, what I want to do now is I want to substitute the quantity into the demand curve to compute the maximum price consumers want to pay at that quantity, right? I'll do something here real quick. I moved the demand curve down. Well, maybe I'm not going to do that. I'll just keep it this way. Keep it simple. Okay, one way to do this is this, right? I got my new quantity here, right? 2.84. I can do this. I can replace the Q with 2.84, right? What do I get? My new quantity is 2.84, right? Right here. I want to plug that 2.84 in the demand curve. That gives me the maximum price consumers are willing to pay at that quantity, right? That's the maximum price consumers are willing to pay. So 1.40 in my case, because you have to round to 2 decimal places for dollars. You see that? So I took this quantity here. I took this quantity here, and I replaced Q with it, right? Replaced Q with it. And I rounded this value to 2 decimal places. Questions? Right? I'm gonna change that back to Q. Notice I have a little dot here, right? I have a dot here. But to do this, you have to put a dot between your slope and your Q. You have to put a dot in there, right? For multiplication. That's a dot, right? And there's a dot here, right? Okay, now I'm going to take that reduced quantity, the goal of the policy. I'm going to plug it into the supply curve. Now, what's the lowest price firms are willing to accept to supply that quantity? Well, that's in my case, 0.69. You see that? Now we're plugging the 2.84, that the goal of the policy, in my case, 2.84, into the supply curve. And I get a price of 0.689 or 69 cents, right? Any questions on that? Now, another way to do it is this way. I could come down here, I'm gonna get rid of that. I'm gonna come down here to 7. I'm gonna type X because this model X and Q are the same, right? This is a math program, not an econ model, right? So I'm gonna, Q is X, right? Q is X. The Q axis is the X axis, the horizontal axis. Everybody got that? Again, this is a math program, not an econ program, right? So I have to use X here. Now I'm going to graph a vertical line at that new quantity, 2.840. I'm going to modify it. I'm going to make it dashed. I'm going to shrink the width. Okay, so it's a dashed line, right? Notice when I put in x equal 2.840, again, that's my new quantity, right? I get a vertical line that passes through the demand curve, right? The first number is the quantity, 2.84. The next number is what? That is the maximum price consumers want to pay for 2.84 billion cigarettes. They'll pay up to, in my case, $1.40, right? That's why I put 140 there, right? Now down here on the supply curve, right? On the supply curve here, at that quantity, the lowest price firms will accept to produce this quantity is 0.69, right? Dollars. Everybody see that? Any questions on that? If you're in a situation where you have a gray answer box that's green, you can't change it, right? So if you get a wrong number, don't guess. Make sure you say Hal, H-Dog, whatever you want to call me, Dr. Snark, Professor Snark, whatever you want to call me. Hal, your pal. You can say pal, right? If you have a red box, don't guess. Make sure you buzz me and I can help you get the right answer. Otherwise, you'll have to do it over again with a new problem, new demand, new supply from the beginning, right? Because I'm trying to limit guessing, right? We don't want to be guessing. We want to practice right the first time, right? So if you get a red box, right, and don't spend your second attempt on that red box with a guess. Make sure you buzz me. That way you don't have to do it over, right? Now, the difference between the above prices gives the per cigarette tax that is needed to reduce annual New York City cigarette consumption by 20%. So all you do here is you take the difference of these two, right? And you can do that right over here. I can do 1.40 minus 0.69. And I get a tax 0.71. Can we see that? Notice when I hit enter, what happened to my supply curve? What happened to my supply curve here? That blue line wasn't there before, right? Y'all see that? When I type in my tax and I hit enter, all of a sudden I have a new curve in here. The supply curve shifted up. Why did the supply curve shift up? Who are we taxing?
When I put in that number, it said mine was wrong.
Okay, let me have you share your screen.
Okay, give me 1 second. Can you see it?
Yeah.
Okay, so I don't know if you, sorry if you see my background,
Can you scroll up?
but
Can you scroll up? Okay, so go back and put in the 2.984 in the demand curve. Put it in both of them real quick. No, right there, right there. Yeah, times that by 2.984.
right here.
Yeah. Get rid of the Q.
Okay.
Yeah.
Sorry, it wasn't deleted.
Yeah. And then times 2.984. Are you on a tablet?
No, this is my MacBook.
Oh, okay. All right. All right. So now you have 1.43 minus 0.6. Try this. Try typing 1.4314. 4314 and then 6854. 6854. And you get 0.75, right?
Okay.
Try that instead.
Oh, there you go. Thank you.
Cool. Yeah, awesome. Yeah, there's, it's a free program and there's rounding issues with it, but it's free,
Okay.
right? That's why I said if you get a red mark, don't guess. And it would have been a really good guess, but I've done this enough with this program where you want to buzz me in so I can help you get that green check mark right. Otherwise, it's a cool program, right? There's little rounding issues, right? Bugs that I haven't been able to fix. Okay, so everybody's got their tax, right? Everybody's got their tax. Did everybody's graph here show the supply curve shifting up?
Yeah.
Now, when you tax firms, what happens? That tax increases the marginal cost of production, right? So when you hold quantity constant, like say at 5, right? When you go from black to this kind of gray blue line, right? When you go from the black to the blue, that's an increase in the dollars per unit, right? And in your book, you should have learned that mainstream economics considers the marginal cost curve to be the supply curve over a certain range, right, of output. So when you tax firms, you increase their marginal cost of production, which graphically is an upward shift in the supply. Now, when you're holding the price constant, right, if you hold the price constant at 1, right, on the old supply curve, you get 6, but on the new supply curve, you get basically 0, right? So when the supply curve shifts up, that's a decrease in the quantity supplied. That's why we call this blue curve a decrease in supply, right? It's also an increase in marginal cost. So when you talk marginal cost, you're going vertically, right? You're going vertically. So it's an increase in marginal cost. An increase in marginal cost is a reduction in the quantity supplied. So that gray curve, you could call it an increase in marginal cost or a decrease in supply, right? Everybody got that? Cool. All right, now over here at Desmos, what we're going to do is we're going to change the tax. I'm going to change the tax to 0.71. I'm going to hit enter. Whoops. And then I'm going to turn on my supply curve, right? My new supply curve. Notice my new supply curve goes for this point right here, right? My new supply curve goes for that point. Okay. So it shows how the tax, what are we going to put right there? The tax does what? The tax blank cigarette, what? Did it affect the supply curve or the demand curve or both? Had no effect on demand, right? What did it do? It shifted the supply up, right? So cigarette supply, right? It shows how the tax reduces cigarette supply, right? Now the tax revenue that is generated by the tax revenue that is generated by this tax equals $1 billion per year, right? Okay. So all we got to do is multiply the tax right here, 0.71, times the quantity, right? And the quantity is, if there weren't a tax, we'd have more quantity. With the tax, we have less quantity, right? So we're going to multiply by the lesser quantity. In my case, 2.84. And this is in dollars. Oh, yeah, per year. Okay. This is in dollars. So 2 decimal places. 2.01. It's weird. Oh, 2.02. I didn't round it right. There you go. I didn't round it right. It's actually 2.02, right? To 2 decimals, because that 6 makes that a 2, right? So make sure you round it right. So that's a good lesson. Make sure you round it right. Anybody get it wrong? Don't guess. If you didn't get it right, make sure you buzz me.
Dr. Smart, how soon are you gonna post this video on Blackboard?
I'm going to post it as soon as it's processing when we're done. We're almost done with this question, actually.
Okay.
Yeah, I'm going to post it as soon as it processes. So I think about 6.
Okay.
Because it processes through Zoom, and then I have to upload it to my Star Institute YouTube channel, and then I have to copy the embed code and paste it into Blackboard. So it shouldn't take too long. Okay. All right. Now subtracting the initial equilibrium price from Pmax. So original price, that's our original price right there, right? Before the tax, smokers were spending, in my case, 76 cents per cigarette, right? But after the tax, they're spending $1.40. That's the tax plus the price, right? That's the after-tax price. The $1.40, right? So what I'm gonna do here is I'm gonna subtract those two. 1.40 minus 0.76. I get, so the tax consumers pay, this is the amount of tax that is borne by the consumer for each cigarette purchased, right? So the consumers are paying, oh, I got in the wrong. 1.4. I got put in the wrong box. Okay. So the consumers of that 71 cents in tax, in my case, consumers are paying most of it, right? Paying 64 cents per cigarette, right? The tax is 71 cents. Okay, now what I want to do is I want to take that equilibrium price, the original price, and subtract from it the price that firms are willing to accept to produce that lower quantity. So I'm going to come back here. I'm going to change this to, that's my equilibrium price. This is my P min, right? The lowest price firms are willing to accept, 0.07. What does that tell you? Who's being taxed? Who is literally taxed here? Suppliers, right? The evil corporations are taxed, right? The evil corporation is taxed. But who pays the tax in the form of a higher price? Who bears most of the burden of this tax? The consumers, right? Everybody understand that? When politicians say we're going to tax the evil corporation, right? It's possible that they're not really taxing the evil corporation. It's possible that that corporation is able to pass the tax off onto the consumers, right? You see that? And the reason why that is because consumers, in this particular case, they're addicted to cigarettes and their demand is very inelastic, right? They're very insensitive to price change. Doesn't that blow your mind? It should blow your mind, right? The evil corporation is being taxed, yet the consumer's paying most of the tax, right? This is a point where you go, Have you guys ever heard that song, Things That Make You Go, by CNC Music Factory? Well, a lot of the stuff I teach in this class, you want to play that song a lot. Things that make you go, Does anybody find that fascinating? Just curious. No. Yeah, maybe. So though the tax was levied on the suppliers of cigarettes, consumers pay, what percent do they pay? So consumers pay what percent? Calculate the percent, you have to divide portion they pay by the overall tax. You can multiply that by 100. Percents are to 1 decimal place. All right, so consumers pay 90.1% of the tax that is levied on the suppliers of cigarettes. Suppliers pay 9.9% of the tax. Which makes sense because 9.9 plus 90.1 is 100%, right? That's very interesting, right? Very interesting because we're taxing the firms, yet the consumer pays 90% of that tax, right? And here's the kicker. It doesn't matter who you tax. If you tax the consumers, we'd have the same situation. You'd have the exact same situation if you tax the consumers instead of the firms. Okay.
Quick question.
Yeah.
How did you get 90.1? Can you re-explain that?
Yeah. Well, okay, so the tax that my consumer pays is right there, right? The tax borne by the consumer per cigarette is 0.64, right? 64
Right.
cents. So I'm going to take the portion that the consumer pays. I'm going to divide that by the tax per cigarette, right? That's the tax that is passed. This is the law, right? The mayor imposes this tax per cigarette, right? When you analyze how that tax is shared amongst the consumers and the firms, right? The consumers end up paying 64 cents of that tax. The firms only paid 7 cents of that tax, right? So I'm just taking this number and I'm dividing by the tax, right? And I get 90.1 right here in Desmos. See that? This is the tax the consumers pay. This is their burden of the tax. And this is the tax that was imposed per cigarette. You got it?
Yes, thank you.
You know, this is cool because you can't just write my numbers in and not think about it. You actually have to think about it, right? You actually have to think about how to do it. If this were a traditional class, you would just write my numbers, right? And you'd get it right. Yeah, that's how I'm engaging you, right? You have to make the calculation. You can't just mindlessly write down what I write, which I think is the beautiful part about this method, right? And then the firm's portion is my model. They're only paying 7 cents of the tax, right? In the form of a lower price that they're willing to pay or accept, right? So that's 9.9 in my case, right? All right.
Wait,
So
could you
let's
just-
assume the tax delineates addicted smokers from marginal smokers and the global low-cost producer from small marginal producers. Who are marginal smokers? Who are marginal smokers? Well, they're the ones that aren't yet addicted, right? They're the ones that are kind of doing it because it's cool, right? I was a marginal smoker twice in my life, 10 years apart. I went into a bar in the Navy, I went into a bar in Seattle, and I had a few too many beverages, and I decided I was going to smoke that night. And I asked the bartender what kind of cigarettes he had, and he said, we only have Camel unfilters left. And me being the son of alcoholic parents, having alcoholic tendencies, addictive behaviors, I smoked the whole pack that night. And I was green. I was sick for 4 days. And so I didn't touch a cigarette until 10 years later when I was in a PhD program, and my PhD roommates and I went to a small town near campus, well, 30 miles away from campus. We're at a bar. They were smoking cigarettes. So I thought, I'm going to ask the bartender for some cigarettes. And he again said, all I have is Camel Unfilters. And I smoked the whole pack that night. And I haven't touched a cigarette since because it made me even sicker when I was 10 years older, right? Now, if I did it a third time, I'd be insane, right? I'd be expecting a different outcome, right? So I would be considered a marginal smoker. Well, if you're going to raise the price on me, I'm not going to smoke anymore, right? So the addicted smokers, they need the cigarettes. They're addicted to them. The marginal smokers, they're just doing it because they want to look cool, maybe, or they like the taste of it and they haven't gotten addicted yet, right? And then we got the global low-cost producer from the small marginal producers. The small marginal producers are like, vape shops, right? Independent vape shops or something, right? Little independent shops, or maybe a shop in New York City that rolls cigarettes by hand and sells them, right? In a fancy shop, and it's a gourmet tobacco shop, right? I've never seen one, but I'm just imagining that there probably are those, right? And a black market forms to satisfy the demand of the marginal smokers. Now, somebody mentioned earlier that marginal smokers can be young people, right? People under the age of 18. They have to go if they want a cigarette, they have to go to the black market. Prior to the tax, the number of cigarettes produced by the global low-cost producer was what? So the global low-cost producer is this part of the supply curve, right? This part of the supply curve here. The marginal smokers supply these cigarettes, right? The marginal firms supply these cigarettes. These are the gourmet cigarettes that are rolled in a special shop, right? So prior to the tax, the number of cigarettes produced by the global low-cost producer is 2.84. Right? And the number produced by marginal producers is the difference in these two numbers, right? Marginal suppliers supply the quantities that are between these two dots, right? They're supplying the quantities between these two dots. So the two quantities are 2.84. Right? We got this quantity here, and we got this quantity here, right? So the marginal suppliers are supplying that quantity, right? 3.55 and 2.84 in my model. Okay, so the number of and the number produced by marginal producers is 0.71. Again, when you add this to that, you get the original equilibrium, right? When you add those two numbers, you get this value here, right? 3.55. The number of cigarettes smoked by addicted smokers was, remember, the addicted smokers are this part of the demand curve. This guy here is the most addicted consumer of cigarettes. This is the addicted cigarette smoker with the smallest addiction. This is a cigarette smoker with the biggest addiction, right? So this would be 2.84. And the number smoked by the marginal smokers, the ones that aren't addicted yet, would be 0.71. Yep. After the tax is levied, the number of cigarettes smoked by addicted smokers is still 2.84. Right? They're addicted. They don't change their behavior. The number smoked by marginal smokers is, again, 0.71. But where are they getting them from? Getting them from the black market, right? See that? The marginal smokers go to the black market.
Question.
Yep.
It's saying mine is wrong because last time I had to round it up.
Yeah, let me have you share.
746.
Go ahead and share,
Okay.
Madison.
Okay. Give me 1 second. Can you see my screen?
Yep. Mm-hmm. Yep. Okay, so you
Okay,
had
so this is the number right here.
yeah.
And last time I had to round it up, so I got, 0.75, but now it's saying it's wrong. So do I try the 4.6?
Yeah, hang on one second. I'm gonna
The
open up the key.
7.46.
I'm gonna open up the key.
Okay.
Yeah, I gotta figure out how to get rid of these bugs. Microeconomics and CNT. Gradebook. I'm going to my gradebook right now. Madison Baudoin. Is that right?
Yes, sir.
I didn't get
Yes,
that right.
sir.
Okay. Okay. Oh, remember billions, you want to round to 3 decimal places. Mine just so happen to be 2 decimal places, all right? I don't have to do any rounding for my billions. So you want to put in 0.746.
Put in 0.6.
0.746.
746. Okay.
Yeah.
Thank you.
Yep. Yeah, remember billions smoked is in 3 decimal places. Okay, share. Whoop, I'm sharing the wrong thing. All right, so we're almost done. Okay, does everybody understand what we're doing here? Prior to the tax, the number of cigarettes produced by the global low-cost producers was 2.84 billion, right? Remember this dashed line here, delineates, separates the low-cost producer from the marginal producers, right? So the cigarettes that are, the quantities of cigarettes that are on this supply curve, these are the low-cost producer cigarettes. These cigarettes are the marginal producer cigarettes, right? These are the marginal producers, right? So the low-cost provider is going to sell 2.84 billion before and after the tax. Now it's a big assumption, I know, but it simplifies the analysis, right? It's a big assumption, right? What we're saying is this tax is such that it eliminates the marginal producers of cigarettes, right? Right? So for the marginal producers, it's the difference in these two quantities, right? So 3.55 minus 2.84, right? And in my case, 0.71. Now, with regard to the addicted smokers, they're willing to pay higher prices to smoke cigarettes, right? So the addicted smokers are on this part of the demand curve. The marginal smokers are between these 2 points, right? They're between these 2 points, right? Right? So the difference in these two quantities is the number of cigarettes that the marginal smokers smoke, right? So after the tax is levied, the number of cigarettes smoked by addicted smokers is 2.84 billion, and the number smoked by marginal smokers is 0.71 billion. But the ones smoked by the marginal smokers were purchased in the black market, right? Now, here's the kicker. The number of illegal cigarettes sold in the black market equals what? Well, this is how many that are being purchased. So that's how many that are being sold, right? Or sold, right, in the black market, right? Makes sense, right? This is how many are being purchased in the black market. This is how many that are being sold in the black market. Now, who's making those cigarettes? Right? Who's making those black market cigarettes? Who do you think's making them? Now, they're not, the low-cost producers not selling them in the black market, but do you think they're making them? Somebody's got to make them, right? Somebody's got to make, if we assume there's no criminal element here, somebody's got to make those low cost or those additional cigarettes, right? So the low cost producer will produce more cigarettes, in my case 3.55 billion, right? For holding the criminal element constant, right? And the marginal producers are making 0 billion cigarettes, right? Everybody understand that? Somebody's got to supply those cigarettes, right? So what ends up happening is maybe in an area where there's no tax, right? Buyers from New York City will go to states where the tax is lower, a lot lower, maybe 0. They'll buy a bunch of cigarettes in a different state, and then they'll bring them in to New York State illegally. And so the low-cost producer is making those black market cigarettes. They're not selling them in the black market, but they're making them. And because they're making them and they're being sold, maybe they're being sold in a different state, right? So some entrepreneur, some criminal entrepreneur, an entrepreneur engaging in criminal activity goes to a different state, maybe New Jersey or maybe North Carolina, buys 0.71 billion in cigarettes and then brings them illegally to New York City and then sells them tax-free, right? So who do you think's in favor of the tax? Who do you think's in favor of the tax? Do you think the marginal producers are in favor of the tax? No, because it puts them out of business. Who's in favor of the tax? Philip Morris, the low-cost producer. That's another thing that will make you go, right? The low-cost producer, in this case, the cigarette markets in America, we're talking Philip Morris, right? They're probably okay with the tax, right? What do you guys think of that? We're done now, right? We're done?
I was gonna say it's another question, a whole nother question.
Oh, there's another question? Oh,
Yes, it's 2 of them.
okay. What I'll do is I'll make this video and I'll post it on oh yeah, there's 2 of them, isn't there? Yeah, I took a little too long to present that. When I present to myself, I take usually about 15-20 minutes. When I'm going through the model and the stories, it'll take more. But what I'll do is I'll make a video, unless you want to stay on. You guys want to stay on for this one won't take very long. If you want to leave, you can, but I'll make the video right now. Any questions on this particular one though? Isn't that fascinating though? Right? That's fascinating, right? One, the first fascinating thing is the firms are taxed, but the consumer pays most of the tax because they're addicted. The second amazing thing is the low-cost producer benefits from the tax because their sales go up from 2.84 to 3.55 because the tax eliminates their competition. Did it have an overall effect? Did it have an overall effect on the quantity of cigarettes smoked? No, right? Because the marginal smokers get the cigarettes that are now being produced by the global low-cost producer. They get them in the black market, right? I'm hoping that you guys are minds blown by that, because when I came up with this model, I was like, wow, that's pretty cool. I don't know. That's just me though. So what I'll do now is I'll make the next video. And if you want to call it a night, you can. If you want to stay on with me, you can. But I'm gonna end this video.